So in this video, we're going to finish sample 1 questions, which are the shorter response questions, and we're going into the sample 2 paper. All right, so this question was on the test. I'm going to go through this kind of quickly. For the exact value of P, remember that all of these right here, the probabilities have to add up to 1, which is 100%. So if you add up all these numbers right here and subtract it from 1, you're going to get that P is equal to 4 out of 18, which is the same thing as 2 out of 9. Okay. Calculate the expected score. Just to refresh your memory, you have to do -3 times 1 over 18 plus -1 times, we just found out that P is 4 over 18, plus, and you keep going until you do 5 times 7 over 18. You hit enter in the calculator and you get either 11 over 6 or 1.83. Okay, so this one on the video key, I did it a different way that I'm going to show it to you right now. You pick whichever way you like better. So total score of -3. The only way to get a total score of -3 is if you have -3 and 0 and you add them, or you do 0 and -3. So you could do this in a tree diagram. If you have a -3, the chances of getting a -3 is going to be 1 out of 18, looking at the probability distribution at the top right here. And then if you get a -3 on the first roll, you could get a 0 or a -3. To get a 0, the expected probability is 3 out of 18, so this is going to be 3 out of 18. So you have to take those right there and multiply them together, which gives you 3 out of 120, no, 3 out of 324. Okay. -3, -3, when you add that together, that gives you -6, so that doesn't count. If you get a 0 on the first try, the possibility of getting a 0 is 3 out of 18. And then on the second try, you could get either a 0 or a -3. And again, for the 0, we don't really care, but for the -3, the probability is 1 out of 18. So when you multiply those two right there, you're going to also get 3 out of 324. And since it's one case or the other, you're going to take those two numbers right there and add them together. That's 6 over 324, which is the same thing as 1 over 54. Okay, you could put it as a decimal, that's fine as well. Alright, so Mr. Burke teaches a math class with 15 female, 6 female and 9 male. Find the probability that on any given day he chooses a female student to answer a question. So there are 6 female out of 15, so that is 6 out of 15, which you could reduce to 2 over 5. Okay, so 6 females, total 15. The first month he's going to teach his class 20 times. Find the probability that he will choose a female student 8 times. So, okay, so we have exactly 8 that we want. Which in the calculator is binom PDF. Binom PDF. And for this one, he's teaching the class 20 times, so the total is going to be 20, comma, he is choosing a female student, that is his probability of success, so we just found that out, which is 2/5. So 2/5 is going to be the probability, and then the number after the exact is 8. So you put this into the calculator, hit enter, and your answer is going to be 0.180. Next one, find the probability he will choose a male student at most 8 times. So that means that he wants that to be less than or equal to 9. So what you're going to do is at most is binom CDF, and it's still 20 times that he's teaching the class. He now wants a male student. So if you can have a female student, if you can choose a female student 2 out of 5, then the males are going to be 3 out of 5. So that's the chance of getting a male, or you could have done 9 out of 15, same thing. And then he wants at most 9 times, so you're going to put 9 in the calculator, and that is about 0.128. Okay, and same thing with this. This is about. All right, so now we're going into the sample 2 papers, which are a little bit longer. So Ollie has installed security lights. Let me just go ahead and put this down a little bit. All right, so we're looking for CAB, right? So we're looking for angle CAB. So CAB, which is this angle right here. All right, so that is completely doable. Let's talk about what it is that we have here. So we have an angle, and we have the side that's opposite, and we are looking for this angle, and we have the side that's opposite. That sounds like it could definitely be law of sines. So just to refresh your memory about what that is, law of sines is you have the A over sine of A is equal to B over sine of B. This is in your formula booklet, just as a heads up. So we have to just go ahead and just plug this in. So if we go ahead and we start with this side right here, so this is the one that's opposite, right? So 6 is opposite this angle that we're looking for. So we know that 6 is going to be the number on top because that's a side. The angle is this angle right here, which is the one we're looking for, which is CAB. So sine of angle CAB is equal to, and we're going to put it over the one that we know. So this right here is our side, which is 4.5. Why does my 4 look like that? 4.5 over the sine of 15. So to do this, all you have to do is cross multiply here. So 6 times sine 15. Remember to make sure that your mode is in degrees. Alright, so I just went to my calculator. Refreshing your memory, your mode has to be in degrees, okay, because this is 15 degrees, so on and so forth. So your mode has to be in degrees. So to do that, you move the calculator down, go over, hit enter, and then you could do second quit and type in 6 times sine of 15, right? So you're going to get that. So you get, when you multiply this right here, we just got that is equal to that 1 point whatever. And so over here we have 4.5 times sine of CAB, which is what we're looking for, is equal to that 6 sine of 15 number. What is with my handwriting today? Whatever. And then we're going to divide both sides by 4.5. This cancels out right here. So you're going to take the number that we got, which is this right here, and we're going to just divide it by 4.5. 4.5, hit enter. All right, so now we know that the sine of CAB is equal to about, what do we have, 0.345, 0.345, but we don't want what the sine of that is, we want what the angle is. So to do that, you have to hit second sine, and then go up, grab that answer, hit enter, and it gives you that it's about 20.2 degrees. Right, so CAB is about 20.2 degrees. Okay, about. All right, so we just found out that this right here is about 20.2. Okay. Point B on the ground is 5 meters from point E. So they're telling us that this whole thing right here is equal to 5 meters. He is 1.8 meters tall and is standing at point D, so this is where he is standing. All right, and then he walks towards point B, okay? All right, fine. So find the distance that Ollie is from the entrance to his house when he first activates the sensor. All right, so this is going to be a little bit harder, but let's go ahead and get started. Let me just go ahead and change colors. So we know that this is 15 degrees, this is 20.2, so we can easily find this angle right here by subtracting both those from 180. So you do 180 minus 20.2 minus 15, and that's going to give us 144.8. Alright, so I'm going to go ahead right here and just put our steps down. So first thing we did is we did 180 minus 15 minus 20.2 to give us 144.8, which is angle CBA. So CBA. Again, please forgive my handwriting. I don't know what's going on with me. Anyway, All right, so now that we have that, the next thing that we can do is let's go ahead and find this angle right here. So we know that this whole thing right here is a straight line. So that's 180 degrees minus 144.8. So step B is going to be 180 minus the angle that we just got, which is 144.8, which is 35.2. Okay, so this angle right here is 35.2 degrees. All right. So now we know that this person, Ollie, right here is going to be, his height is 1.8, right? Yeah, 1.8 meters tall. So 1.8 meters tall. All right, that's how tall he is. And we want to know how far he's going to be able to go before he activates the sensor. Okay, so let's go ahead and see if we can take, this is now part C. All right, so I'm going to just go ahead and redraw that triangle that I just drew, which this is 35.2. So 35.2. I know his height is 1.8 meters, and this is a right angle. Okay, so we can use some right angle trigonometry here. So just 1.8, right? 1.8. All right, so we want to go ahead and see if we can find out what this distance right here is from here to here. So from where Ollie is. So let's go ahead and call this A. All right, so we have an angle. Let me just go ahead and switch colors. We have an angle. We do not know what the hypotenuse is, neither do we care. We don't care about that distance. We care about this right here. So we have opposite, which is OPP, and adjacent, which is ADJ, right? So out of SOHCAHTOA, which one has opposite and adjacent, right? Tangent does. So we can go ahead and set up tangent of, we have our angle, 35.2, is equal to opposite, we know is 1.8. So 1.8 divided by the adjacent side, which is, you don't know. Anytime you have this, you can just go ahead and switch these two right here. Or you could do the same thing as cross multiplying and dividing by 1. So in the calculator, all you have to do is 1.8 divided by the tangent of 35.2. Hit enter, and you're going to get about 2.55 meters. So we know that this distance right here is about 2.55 meters. Okay, so now we found out that, right? So we found out that this distance right here is about 2.55. So we know that the whole thing, right, from B to E is going to be 5. And we just found out that this distance right here is 2.55. So to figure out what this distance right here is, which is our remaining amount, all you have to do, last step, is do 5 minus that. So step D is going to do 5 minus the measurement that we just got, which is 2.55. And our final answer for this question is 2.45 meters. Okay? I know that was a lot, but that is also why it was worth 5 points. All right. So for this one right here, we have, I know you all did something like this last year, but you do need a couple of, the TBM solver does go ahead and help us with this. So give all answers to 2 decimal places. You should definitely make a note of that. So Brian decides to the price of the car is 14,000. Can't afford the full amount, so there's 2 choices. Okay, so one of them is 14% compounded quarterly. So let's go ahead and see if we can figure out each of these right here. So we have our N. So let me just show you where we go in the calculator for this. Okay, you have to hit apps. Option number 1, which is finance, and TBM solver, which is this right here. So this is where we're going to go ahead and input our data. So let's go ahead and figure out what each of these are first. Okay, so our N is going to be, we take a loan of 6 years, and it is compounded quarterly, which quarterly means 4. What you're going to do for n is do 6 times 4. So the number of years times how many payments there are. The interest rate, the percent, is equal to 14%. So we could put 14 there. PV is going to be, right, how much he's borrowing the loan for, which is 14,000. So 14,000 is going to be the price. The payment is what we want to go ahead and find out. Our FV, we're going to leave that, our future value, we're going to leave that as 0, because after he pays off the loan, there is there's nothing else that he owes. That is going to be 4, which is how much it's compounded, and the compound per year is also going to be 4. Okay, so now we're going to go ahead and plug this into the calculator. Okay, so I just went ahead and plugged this into the calculator. For n, I put in 6 times 4 and it converted it to 24 for me, right? You can read what the rest of it is. So we are looking to see, for part A, it says find the repayment made each quarter. So we want to hit payment right here, and all we're going to do is hit alpha, which is the green button, and enter, which is solve, and it gives us $871.82. Okay. So that is how much he is paying for each quarter. So that's $871.82. Well, this is not dollars, but this is pounds. So symbol looks something like that. All right. So that's the answer for the first part. For the second one, he is paying, right, this amount, which is $871.82. And he's paying that over 24, right? So 6 years times 4 times a year. So we're going to do 871.82 times 24. So 6 times 4 is 24. And that number is going to give us 20,923.64. Check my math, but that is how much I got. Find the interest paid on the loan, right? So all you have to do for that is take this number right here and subtract it from the original cost of the car, which is 14,000. So 20,923.64 minus 14,000 is going to give us $6,923, well, pounds and 68. Okay, so that is going to be the answer for part 3. All right. Good, so finance option A is done. All right. Finance option B, the second amount that he could do is he could do a 6-year loan. Uh, we're not given the annual interest rate. It's a nominal one, and it is compounded monthly. So that is 12, right? Find the amount to be borrowed for this option. Okay. So now we have something similar, right? So we have 12 times 6 years, right? So it's compounded monthly. So that's going to give us 72. Our interest rate, we do not know, right? So we're going to have to find that. Our present value is going to be, if we take a look at it, okay. All right, so I noticed in setting this up, yeah, we didn't answer part B, right? The first part. So I found the amount to be borrowed, right? Because that's what we need. So to find that out, we know that the car costs $14,000. $14,000. And he already put, it says terms of the loan require a 10% deposit and monthly repayments of £250. Okay, so what we're going to do is we're looking to see how much is going to be borrowed, right? So he's already paid this 10% deposit. So we're going to, from the cost of the car, we're going to take 10% of that amount and subtract it from there. So we're going to do 14,000 times 10%. And then that's going to give us the amount that he is borrowing. So that's going to be, if you plug that into the calculator, you're going to get 12,600. So our present value is going to be 12,600. But we'll go ahead and do this in order. So now it says find the annual percentage rate, right? So find the annual rate. So what you do for that one right there, let me just go ahead and pause this real quick. All right. So the reason why I paused it is because I wanted to plug it into the calculator. So our N is 72. Our interest rate is what it is that we're looking for. Our present value is, we're taking out the loan for 12,600, so we are getting that amount. So find the interest rate is what we're looking for. But we do know that there are payments of, right, monthly payments of 250. So I went to my calculator, and since it's a payment, I put a negative sign. That's this one right here. This is the negative. This is the minus. So don't put this. Excuse me, I'm gonna sneeze. Excuse me. All right. Our future value is 0. Um, the principal per year is going to be 12. That's how much is being compounded. So 12 and 12. All right. So now we're gonna go over here. Sorry if I scared you with my weird sneeze. And so now I'm gonna do alpha y equals to find out what the interest rate is. So perfect right there. So we have, this is about 12.56. Okay. So the interest rate is about 12.56% is going to be our rate. And so now what we want to do is, it says state which option Byron should choose and justify your answer. So let's go ahead and think about that, right? So how much interest is being paid, right? So over here it's 6,923, and over here for this one it's going to be 12.56%, right? So we look and see which one is going to be the less. So this is 12.56% is the rate, and over here it's 14. Let me just go ahead and highlight those two. Right, so since the 12.56 is a lower interest rate, B is going to be the less, where there's less interest paid because it's a smaller interest rate. So he should choose B, option B, because it says justify your answer. We want to state why, because he is paying less interest. He is paying less interest, which is why B is the better value. All right. So next one, Byron's car depreciates. So it depreciates, which means it goes down at an annual rate of 25% a year. This is real life, okay? So let's think about it real quick. All right, so find the value of his car after 6 years after it is purchased. So there is a formula for that. So it's FV. This is in your formula booklet, so you do not need to memorize it. You just need to know that this is what we're going to use. R over 100k to the kn power. All right, so let's go ahead and plug numbers in here. So we have, to get the future value of this, it's going to equal to, the car costs 14,000, so that's our present value, times 1 minus, right? So it's 25%. You can see that right there. So it's 25 over 100. Right? Doesn't say that it's being compounded anything, so we're just going to leave that k as 1. And that is, we're looking for 6 years after it's purchased, so that is our n. So our n is 6. So you take this whole thing right here, plug it into the calculator, and that is about 2491.70. Okay, so that is our final answer for part D. I do want to go back real quick in case you're confused about this part right here about the interest. Let me see if I could just switch colors. Let's do purple. So if you wanted to find out how much interest he's actually paying on this, instead of just looking at the percent, we know that he is, for option B, he's paying 250 pounds per month times 72, because 12, right, it's compounded monthly times 6 years, so that's going to be times 72. And then from that, we are going to subtract the 12,600 that he is taking out that he's borrowing. So it's going to be minus 12,600 to find out how much interest he's paying. So that interest right there is about 5,400, right? And we can see that 5,400 is less than 6,923, right? So that's another reason why option B is less. All right, moving on to the next question. Okay, so again, these are pretty long questions, but it's okay. They're worth a lot. So this is 14 points. So we have to remember that whenever we have a question that looks like this, right? These numbers right here have to add up to 1. So 80 plus 20 is 1. Okay. So over here we have 10. So we know that this number right here has to be 90. So if there's 10% that are yellow, then the percent that is not yellow is going to be 90%. So let me just go ahead and get my regular pen. So this is going to be 0.90. All right. And then let's take a look. And it says, so 30% of the crescent moons are colored yellow. So this is crescent moon, yellow, that's 30%, so that's going to be 0.30, which means that if this is 0.30, 0.30 minus a dollar is, this is 0.70, so 0.70 of them are not going to be yellow, okay? Okay, good. So the first part is done. It says get using the information, copy and complete the following tree diagram, so that part is done. All right. So for the next one, it says find the probability that the sweet is yellow, okay? Find the probability that the sweet is yellow. So to do that, there are a couple of different options. Since it's yellow, let me just go back up here. All right, let me get my highlighter. All right, so this is a path that ends in something that is yellow, and this is another path that ends in something that is yellow, right? This is not yellow, this is not yellow. So what we have to do is we have to take those and find out what that percent is going to be. So you do 0.80 times 0.10, so 0.80 times 0.10, and or we could have this path, so this is 0.20 times 0.30, so 0.20 times 0.30. You plug that into the calculator and you're going to get that this is 0.14. So that is the probability that it is yellow, that the sweet is yellow. All right. The next one, given that the sweet is yellow, find the probability that it is star-shaped. So the formula for given is the probability of, so sweet is yellow. So, okay. So given that the sweet is yellow, find the probability that it is star-shaped. So star-shaped, given that it is yellow, the formula for that is going to be the probability of both star and yellow over whatever the second one is, right? So the probability of yellow. So didn't we just find that? The probability of yellow was 0.14, okay? So star and yellow, so star shaped, which is here, and yellow, is you take 0.10, 0.80, and multiply them. So 0.80 times 0.10, and that's going to equal 0.571, okay? So 0.571. Forgive all this writing over here, whatever. All right, so that is parts A and B. Good. That was 6 points that we just got. Now, according to the manufacturer specifications, the color in each variety pack should be distributed as follows. So this is what the regulations say. This is what actually happens. So he opens a pack of 80 sweets and records the frequency of each color. So write down the null. So he's going to do an investigation. It's very good because a lot of you have chi-squared as part of your IAs, so this might be a good refresher. So he's doing a chi-squared goodness of fit test at a 5% significance level, okay? So it says write down the null hypothesis. So null hypothesis, remember, is that one variable is not dependent on the other. So basically what we're saying here is that the colors are basically distributed according to what the manufacturer says. So colors are distributed, right, because they have no, they're independent of each other. So they are according to manufacturer. Manufacturer specs is going to be our null hypothesis. So now we are going to copy and complete the following table in the answer booklet. So remember that your answers for part paper 2 have to be on a separate sheet of paper, so just make sure that you do, when it says copy and complete, you have to actually copy this table and complete it. Okay, so let's go ahead and figure out how we get this. So he's opening up a bag of 80, right? And what we have to do is, to find out what this number right here is, we have to take the percentage, right? Because this right here is 15% times 80 sweets. So again, to figure this out, you're doing 15%, because this is what the manufacturer specifies, times there's 80 sweets in the bag. Okay, so 15% of 80 is 12, because it's 0.15 times 80. All right, and you do the same thing here. So you're, for this one right here, you're going to do 0.25 times 80. And that is going to give you 20. For the green, you're going to do 20% of 80, which is 16. So this is 16. This is also 16. 20, half 10 is half of 20, so half of 16 is going to give us 8 right here for yellow and 8 for purple. All right, so 8 for yellow and 8 for purple. For the next one, find the degrees of freedom. Okay, so all you have to do for degrees of freedom, just to refresh your memory, hopefully this is a refresher, is you take the categories that we have, right? So there are 1, 2, 3, 4, 5, 6 categories. So you take the categories that we have, which is 6, and subtract 1. So 6 minus 1 is going to give us 5. So the degrees of freedom is going to be 5. 5 degrees of freedom. Good. Now it says find the p-value for this test. Okay, so I'm going to go ahead and just pause the video real quick so I can just go ahead and show you how to plug this into the calculator. Alright, so hopefully you're just doing that with me. So all you have to do next, after you plug the numbers in under L1 and L2, right? So your L1 is going to be your observed frequency, which are these numbers right here. And then expected frequency, which are these numbers right here. And then to find the p-value, all you have to do next is you hit stat. We're going to go over to, we are conducting a test. Specifically, this test is going to be the chi-squared goodness of fit. So we're going to look for that. So chi-squared goodness of fit, I just pressed the up arrow to go all the way down, and it's right there. So we're going to hit that. Observed is L1, that's what we put. Expected is L2, so we're good so far. Degrees of freedom is 5. And now we're going to go ahead and calculate this. Okay, so you're going to hit calculate. And it tells us that the p-value is 0.469. So p is about 0.469. Wow, this song is a throwback. There we go. So there's our p-value. And then it says state the conclusion of the test, give a reason for your answer. So basically, since this number right here, the 0.469, is greater than our level of significance, which is 5%. So since, I should just type this because my handwriting is horrible. Since 0.469 is greater than 0.05, right? 5% level of significance, two places to the left, that's 0.05, comma, we're going to accept the null hypothesis, which is the manufacturer specifications. Okay, so that is part G. We're done. All right, question number 6. Whew. All right, so Malvern Aquatic Center, da da da. You can read. Pause this video, please, and go ahead and try this question yourself. You have done Pearson's value before, so pause and make sure that you can actually do this yourself. Alright, I did a better job this time of pausing the video so I can plug the numbers in. Alright, so once you plug the numbers in, you need to make sure that since we're looking for the R value, you need to make sure that your diagnostic is on. So you're going to hit mode, go down to the bottom, start diagnostics, stat diagnostics, you want to make sure that it's on. So go over to not on and hit enter, and hit enter. And then you're going to hit second quit, and you're going to do stat, go over to calc. Option number 4 is linreg. You're just going to hit enter a whole bunch of times until it gives you your R value, which is 0.909. Remember, we're never using R squared for SL. All right, so R is equal to 0.909. Beautiful. So this indicates that there is a strong positive relationship. Okay, strong positive relationship between the two scores, Stan score and Minson score. Write down the equation of the regression line. So you just need to go back here. So here's your A, which is your slope, and your B is right there. We call slope gradient. Okay. So now all we're going to do is we're going to take this and write this as an equation. So y is equal to 1.14 plus 0.578. Now it says use your regression, da da da. So you're going to take the 10 right here and you are going to plug it in for our x. So right, so you're going to plug in 10 for x here. So 1.14 times 10 plus 0.578. Let's see, let's do that. So 1.14 times 10 plus 0.578. And that's going to give us 11.978, which rounded to 3 significant figures. Yeah, so 11.98. Well, that's 4 significant figures, so that's going to be 12.0. Okay, so this answer is going to be 12.0. Good. So state whether this estimate is reliable. So since 10 is not in the data range, right? So if we look over here, if we look, right, 10 is outside. So the highest number here is 9.5, highest number here is 7.5. So 10 is outside the data. So we're going to say it is not reliable. Not reliable because, and spell the word out please, but x equals 10 is outside the data range. Outside the range of data. And also we can't have a score of greater than 10, right? Because if you look at it, it's a score that's out of 10. So that's another reason why also, right? The highest score that you can have is 10, so how can you have a score that is greater than 10? That will not make sense. Alright, whereas this one is 12.0, that doesn't make sense. Alright, so now we're going to do some, they frequently do this, where they take Pearson and then ask a question about Spearman as well. So now all you have to do is take the numbers that we have above and put it, like rank them. So let's go ahead and do that. So over here, they have already done the first one and the fourth one for us, right? So they have number 1 is the highest. The second highest is going to be E, which is right here. So that's going to be 2. And then if we look, yeah. So these two right here are the same. So 6. Oh no. Anyway, they've already done that H, right, is going to be in the fourth place. So that means that F is going to be in the fourth place and D is going to be in the fourth place as well, because all of them are the same number. Remember that this is going to be ranks 3, 4, and 5. So 3, 4, and 5. So if you find the average of them, so add them up, divide by 3, and that gives you 4. That's why 4 goes in all of those. So now after 5 comes 6. So the next number that is the highest is going to be 3. So that goes right there. So that's going to be 6. This is the 7th, and 8th is already done for us. Okay, good. Now you're going to take these bottom numbers right here and rank them also. So the highest number is this 9.5, and then 9 is going to be, so this is 2, this is going to be 3. Now we have 4, there are 2 of them, right? Did this, so we have 7.2. So again, this is for the 4th place and 5th place, which if you average 4 plus 5 divided by 2, you're going to get 4.5. So this is going to be 4.5. And again, they've done this one for us. So I could have just avoided that, but anyway, whatever. And then this is going to be the next highest, 7th, and the last one. Okay. So now you're going to take this, and we're doing the Spearman's rank coefficient, correlation, right? Correlation coefficient. So you're going to plug this under L1, plug this under L2, and you're going to find the Spearman's rank, which is 0.933. Please do this yourself. Do not just take my word for it, okay? And basically comment on the result obtained. This is also another strong positive correlation between the two ranks. Part F. So the commissioner believes Minson's score for competitor G is too high, and so decreases the score from 9.5 to a 9.1. So let's take a look at that. So 9.5, here's Minson's, right? So that was already the highest number, right? That was slot number 1, if you take a look at that, right? So it doesn't matter, because if you look, the next number after 9.5 is 9, right? So even if you decreases this, it's still going to be in first position. It's still the highest rank. So you could just say for this one right here, this number right here is still going to have, so competitor G is still going to have the highest rank. It's still going to have the rank of 1. The rank of 1 for Minson. Right? That's not going to change. Therefore, RS, which is the Spearman rank, does not change. Okay, good. All right, we are making pretty good progress. All right, for the next one. If you need to take a break, take a break. Wake me up. All right. So, sorry, I got caught up in music. All right. So for this question, for number 7, um, at some point we are going to have to do some calculus, which is from here down. But let me show you the surface area, so at least we could earn these 2 points, plus these 2 points, plus these 3. So we can earn 7 out of 15 without doing calculus. But let's move on. So calculate the surface area of the box. So remember, surface area is finding the area of each of the faces and adding them together. So there are 6 faces. So the formula is 2 times, right, the area of this right here, which is, this is 8, this is 3, so 2 times 8 times 3, plus, we look at this face right here, and there's 2 of them as well, so that's going to be 2 times 4 times 3, so 2 times 4 times 3, plus, and then for the last face, which is right here, the one on top and the bottom, so that's going to be an 8 by 4, so 8 times 4. And when you do that, you plug that into the calculator, you're going to get 136 cubic centimeters. That's going to be our surface area. For the next one, to calculate AG, alright, so AG is from one corner all the way to the diagonal of the other one. In order to do that, we have to first calculate what AC is. Forgive me, that is a horrible line. What let's see if it'll do it. Don't lose it on me now. Alright, so from AC, you want to calculate what that right there is. Let me just move my crappy drawing. Okay, good. So if you can tell right here, if we look at the bottom of this box, this is actually a right angle right here. So what you have, that's a right angle. So what you have on the bottom is you have something that looks like this. Alright, so this part right here is 8. This part right here is 4. And we are looking to see what this hypotenuse is. So we can use Pythagorean theorem to do that. So 8 squared plus 4 squared. And then we have to do the square root of that. So remember, Pythagorean theorem is a squared plus b squared is equal to c squared. So if we have 8 squared plus 4 squared, that's equal to c squared, but we want c, which is AC, that length. So c is going to equal the square root of 8 squared plus 4 squared, right? So we could do that, plug that into the calculator. I'm just going to go ahead and evaluate that a little bit simpler. So 64 plus 16, right? Plus 16, when we do that, we get 80. So AC is equal to the square root of 80, okay? So that is this part right here. So the square root of 80 is that diagonal. I'm going to go ahead, and why did we do that, right? Why did we do that? Because if we take this other triangle that we take a look at, let's see if I can redraw. So here's A, we're looking for G, and then this right here is C. So what we just found out right now is AC, this is AC, so we found out that AC, which is this right here, is the square root of 80. Let's see what else we know. We also know that GC, which is this part right here, is equal to 3. So we could definitely find out what this right here is by using the Pythagorean theorem as well. So this is AG, which is, let's call that X. Let's get a little bit more room here. So we have Pythagorean theorem, right? So we're going to do AC, which is the square root of 80 squared plus 3 squared is equal to what we want, which is x squared. Okay, so square root and square cancel each other out, so that's 80 plus 3 times 3 is 9. So 80 plus 9 is 89, and that's equal to what we're looking for squared. So we have to do the square root of this right here, which means we do the square root of that. 80 plus 9 is 89. So the square root of 89 is equal to what x is, and if you plug that into the calculator, you're going to get x equals 9.43. Okay, so that is AG. So AG is equal to 9.43. Units are centimeters. Okay. All right. So for the next one right there, actually you can go ahead and stop. But for the next one, all you're doing is you're taking the X, and you're looking to see where the profit is maximized, to maximize the profit. And so all you have to do for that is plug in 0 in for this X right here. Just plug in 0. So we have -2 times 0 plus 220. So that is going to give us 220. I messed up. You have to plug dpdx, which is this right here, and set that equal to 0. So you have 0 is equal to -2x plus 220. When we get into the calculus unit, we will go over this a little bit more. No worries. So you could add 2x to both sides. So plus 2x plus 2x right there. So you get 2x is equal to 220 and x is equal to 110. And if you look at the question, it says find the number of boxes. So x is equal to 110. The sale of x 1,000 boxes. So you have to take the x, which is 110, and so x is 110. So how many thousands of boxes that is the same thing as 110,000 boxes. So find the number of boxes is 110,000 boxes. Okay. All right. Last question. All right. So we have braking distance. I know quite a few of you are practicing for your license or just got your driver's license, so congratulations. Let me just go ahead and talk through this. So braking distance defined as the distance traveled from the brake when the brakes are applied, when you hit the brakes, until when your vehicle comes to a complete stop. So that's called braking distance. The speed, which is meters per second, and braking distance, which is D. Meters of a truck were recorded, so this is what was recorded for a truck. And you're going to see two models here. So for the first one, we're going to call this Model A. So Model A, it's telling us that the distance is going to equal to P, some random number P, S squared plus Q of S. So we're going to eventually go ahead and in part A2, we're going to go ahead and find out what P and Q are. But all we need to do for this first part right here is we're going to find D of 10. So the speed is 10. So we're looking for D of 10. And all you're going to have to do for that is plug in into the formula that we have, which is this one right here. We're going to take this and we're going to plug in 10 for our speed. So that's going to equal P times 10 squared plus, I don't know what the Q is, so we're going to leave that alone, times 10. Okay. And then we're going to just go ahead and solve this. So they did tell us that when the speed is 10 meters per second, let's go over here. So if the speed is 10 meters per second, the d of t, which is our braking distance, d of s, my bad, d of s is equal to 60. So we're going to go ahead and put 60 here. So 60 is equal to 10 squared is 100. So that's 100p plus q times 10. Q10 is 10q, same thing. We can see that everything right here can get divided by 10. So let's divide all of those by 10. Divide this by 10. Divide this by 10. Just to simplify our model. So 6 is equal to 10p plus q. Okay. So that right there is going to be our answer for part A1. Write down a second equation to represent model A. All right, so part B says find the values of P and Q. I need a little bit more space here to do that. I'll just go ahead and extend this page. So to find out what that is right there, we're going to write down our new model that we just found, which is 10P plus Q is equal to 6. I know we had the 6 over here on this side. The reason why I put it the way I did is because the model that they gave us has the number chilling by itself at the end. So 6p plus q. So why does this keep jumping? 6p plus q is equal to 2. So those are our two. We can go ahead and use our graphing calculator to figure out what p and q are. If you do not know how to do that, I noticed that if I take one these right here and I subtract it, this becomes a negative q. This becomes a -6. This becomes a -2. Right? Multiplying every one of these by -1. So 10 minus 6 gives us 4p. The positive q and the negative q cancel each other out, which is good. And 6 minus 2 is equal to 4. So therefore p is equal to 1. Okay? So if p equals 1, I can take that 1 and use it to plug it back in to find my q is equal to -4. So p equals 1 and q is equal to -4. So that is my answer for part A2. So p is 1 and q is equal to -4. All right. So now it says find the coordinates of the vertex of the graph y equals d of s. So all we're going to do is we're going to plug this into our calculator. So find the coordinates. Okay. So let's go ahead and do that. If I take my values that I just got and plug it into my original, which is right here, because it says d of s, right? So I know that p is equal to 1, so I have d of s is equal to 1 s squared, right? 1 s squared. And I know my q is -4, so I put -4s. So this is something that I can just go ahead and graph. All right, so I'm going to go ahead and graph the equation that I have, which is 1x squared minus 4x. And I'm going to go look at my vertex, which this right here is my vertex. So to get my calculator to spit that out for me, I hit second trace, and I'm looking for the minimum. So option number 3 was minimum. So you're going to go somewhere to the left of this minimum, hit enter. You're going to go somewhere to the right of that minimum. And again, you should be doing this on the calculator with me. Go to where you think the minimum is, and you're going to hit enter. So our minimum is 2 comma -4. 1.999 is 2. So we just found out that our vertex, let's go ahead and do this in purple, is 2 comma -4. 2 comma -4. All right, so that is part B. So A is done and B is done. Now for the next one, it says using the values in the table, sketch the graph. And they want us to change the window, so I'm going to go ahead and do that. So hit window, and my s, which is my x value, they want us to go from 0 to 10, which makes sense because we can't have negative speed. And then for our y, they want us to go from -10 to 60. So -10 is already there. I'm going to go ahead and put this as 60. And all you have to do is take this curve right here and just sketch it to get full credit for part C, which is 3 points. And it says clearly showing the vertex. So for part C, this is B. For part C, all you have to do is go something like this. Right, we're going to label it. So this is -10 to 60, and this is from 0 to 10. And we're going to do our best to graph this function that we have right here. We're going to, it kind of looks like a U, but it starts right here, goes down and goes up like that. And that says clearly labeling the vertex. So this point right here is our vertex, and this was at 2 comma -4. You also want to label any intercepts. So this one right here is 4 comma 0. And I can find that by going to the table. 4 comma 0. Boom. And we have full credit for part C. Okay, that was pretty straightforward. Part D, hence identify why model A may not be appropriate at lower speeds, right? So that makes sense because if the speeds are lower, that's like saying that the car or the truck is negative, it has a negative braking distance, which means that it's going in reverse, which can never happen. So we could just go ahead and write that down. So for part D, let me just go ahead and do this. So when, ooh, I need to make that smaller, but when speeds are lower or low, the braking distance is negative, which indicates that the truck is going in reverse. And this is not realistic. Not realistic. Okay. So that is your answer for part D. Let me just go ahead and take this, make this a little bit more legible to us. But just making it smaller so it can fit. You get the point, but let me just try to do this a little bit better. Okay, there we go. All right. So that is part D. Part E, all you have to do for that is take the 20, right, and plug it in for S, right there. So you're doing 0.95 times 20 squared minus 3.92 times 20. That is a straight calculator question. So when you do that, you get 301.6, which is about 302. So 302 meters is going to be your answer for part E. For part F, it says calculate the percentage error. So that formula is in your formula booklet. That is the absolute value of, there's an exact, so VE, which is equal to 320, right? Because it told us that the actual braking distance at 20 meters per second is 320, and then there is the approximate value, which we just got in the previous part, which was 301.6. 301.6 meters. Okay, so now we have to take that and plug it into our formula. So our VA is 301.6 minus our VE, which is our exact, is going to be 320 divided by the exact, which is 320, and then you have to multiply that by 100%. So when you do that, and you plug that into the calculator, you're going to get 5.75% is our percentage error. All right, so that is part F. Perfect. Oh, we're almost done. All right, so for this one, this is actually true, right? When you press the brake of a car or a truck, the car doesn't just stop right away. The car moves forward a little bit at the same speed and then decreases. So what's happening here is it's saying that the truck driver realizes that he needs 1.6 seconds before the brakes are engaged, right? So that's his reaction time. The vehicle is going to travel at its original speed during that time. So a truck approaches an intersection with speed S meters per second. The driver notices the intersection's lights are red and they must stop the vehicle with a distance of 330 meters. All right, so for this one right here, for this part, what we're doing is it says using Model B and taking reaction time into account. So we're using Model B plus reaction time. So we have to remember that reaction time is, he said it takes him 1.6 seconds. So that's plus 1.6 s, because that accounts for the reaction time. And the Model B, they give us Model B, don't they? They do. They give us Model B. Where's Model B? Model B. Yeah, we found Model B over previously. Over here. Yeah, so right here, Model B is 0.95 s squared minus 3.92. So we're going to do that. We're going to do 0.95 s squared minus 3.92 s. So immediately I see that these two can be combined right here. So we have 0.95 s squared minus, when you subtract 3.92 minus 1.6, you get 2.27 s And so now they're asking us to find, they must stop the vehicle within the distance of 330. So the distance is going to equal 330, so we put the 330 there. And then you can use the calculator to go ahead and tell us what the answer for this is. So let me show you how to do that. All right, so if you plug in what's on the left side under which is 330 under Y1, you plug what's on the right side of the equal sign under Y2, and you hit window because we need to change the window. So if I leave it as negative 10 to 10, I want to see what happens here. So over here, I just went ahead and changed this to negative 50 because I know that the max has to be 330. So I just made the max 350 so I can see everything, and I hit graph. So, okay, I see that is my 330, and then I can notice that there's probably a point of intersection over here on the left-hand side, but that doesn't make sense because remember, speed can never be negative. So we can see that the curve's going to come back up here, and somewhere, whatever over here is going to touch. So let's just say I take my window and I want to change my X max. So I want to go over here and let's just go ahead and let's just do 40. And let's see if we see it. If you don't see it, you have to move to the right. Okay, that looks like it's going to be good. So it's probably about halfway, which is around 20. That's my hypothesis. But second trace, I'm going to do option number 5. So I'm going to go closer to that point of intersection, which is right there. Just hit enter, 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 and it gives me the exact value, which is 19.87. Good. So I can say that our speed, is going to be 19.9. So S is about 19.9 meters per second. So seconds to the -1. And that is going to be the maximum possible speed of the truck if it's to stop before that 330 meters. Okay. All right. Good job. I know this was a long one. Sorry.